In question 10, you're given a brick which is in the shape of a cuboid, and you can see its measurements are 2x by x by y, and they're all labelled on the diagram here. And then it tells us that the total surface area of the brick is 600 centimetres squared. And the first part of the question is to show that the volume v centimetre cubed of the brick is given by v equals 200x, take away 4x cubed over 3. Now the really important thing here is to notice that it gives you that the total surface area of the brick is 600, which means you can now create an equation with x and y, and which you'll be able to use to help you find the volume. This is like a restriction that you need to use. So I'm going to work out the surface area. If we look up here, I need to think about getting every side of this cuboid into my equation for surface area. So side 1 is going to be 2x squared, just multiplying those sides together. Side 2 is going to be the same as 2xy. You can see that that length here is 2x along there, which is going to be the same here. So 2x times y. And then this face 3 will be x, y. Again, just following the lines of here. So that's x, so that means that is x. This is y, so that's y. Hence that area is xy. Now that's just one half of the shape that we can see. There are two lots of each face. So I want to multiply that all by 2. And I know that that equals 600 because that's given in the question. Okay, I'll scroll down now. We don't need to see the diagram anymore. I can see there that I can get rid of this 2 quite early on and divide by 2 on both sides. You could multiply it out, that's fine. It would give you the equivalent thing. But I'm going to get rid of that because that just makes it a little bit easier. So I'll write that out again. That's 2x squared plus 2xy plus xy equals 300. These terms are the same, the xy, so I can collect those together. So I get 2x squared plus 4, oh, not 4, plus 3 x y equals 300. I can see in the V that there is no y in there, so I'm going to want to get rid of y at some point. So that indicates that I want to rearrange this equation to get y in terms of x. And you'll see how that comes in handy. So rearranging, I get 3xy equals 300, take away 2x squared, and then I need to divide by 3x, so y equals 300 over 3x minus 2x squared over 3x, and that will give me y equals 100 over x minus 2 over 3x. So I've just cancelled the x's here and cancelled the 3's here. Now I've got to think about the volume. How could I write the volume of this cuboid? So let's have a look at it again. The volume just means multiplying all these lengths here. So that will give me 2x times x, 2x squared times y, 2x squared y. So volume equals 2x squared y. And then the next step will be to substitute y into this equation for volume, and hopefully that will give me the equation that they've shown in the first part. If you only got to say here and then you wrote this should tell you at this point that you want to be losing that y, because there's no y in here, in here. So you want to be getting rid of that. That's why we want to substitute y with something in terms of x. So now I'll carry out the substitution. V equals 2x squared. I'm replacing y with 100 over x, that's what that says, minus 2 over 3x. And then multiplying out, I get 200 x squared divided by x, so x, and then minus 2 times 2, 4 over 3, and then x squared times x, x cubed. And that is what we had up here, so that must be correct. In part B, it asks you to use calculus to find the maximum value of V, giving your answer the nearest centimetre cubed. So if I want to find a maximum value, they occur when the gradient is 0. Because this is a function, we mean the gradient function, so we're using calculus to find dv by dx, which is the gradient function of the volume, and then I'm going to equate that to 0 to help me find the maximum value of V. So doing dv by dx, that's quite straightforward, 200 minus times by the power, so I'm going to times by 3. That's going to cancel with 3 on the bottom, so minus 4x squared, reducing the power by 1. So dv by dx is 200 minus 4x squared. At a maximum, dv by dx equals 0. So I shall equate 200 minus 4x squared to 0. And then I need to solve this equation. So rearranging, I get 4x squared equals 200. That's like moving all of that to the other side, but I swapped it around because I'd rather have x squared on the left-hand side. And then dividing by 4, I get x squared equals 50. So x is going to be plus or minus the square root of 50. I'm going to think back to what the question is about. It's about a cuboid, a brick. So it doesn't make sense for x to have a negative value because it's a length. So I know the maximum will occur when x equals 50. I'm just going to use that, positive root 50. So x equals the square root of 50. Now I'm not done here. The question did not ask to find out when does v take its maximum value. It says find the maximum value of v, which means I need to substitute this back into the formula for v here to find its maximum value. So v equals 200 times root 50 minus 4 root 50 cubed over 3. I won't go through all the working out for that. This is one you could just plug it straight into your calculator. So just be careful that you do that correctly, and you'll find that v equals 943 centimetre cubed to the nearest centimetre cube there, rounded.